The main goal is we want to get rid of the square root in the denominator because fractions are not considered simplified when there is a square root in the denominator. Now, eventually we're going to have to learn a few more ways, a few more strategies to make that happen, but the shortcut is going to work on the ones that you're going to do for this assignment. So a shortcut that can sometimes be used is this property. If you have a square root over a square root, you can rewrite it as the square root of just the fraction, and vice versa. Okay, so in this particular one, I want to rewrite this underneath just one square root. So I'm going to have the square root of 6 over 54. Now this fraction simplifies. I can divide both of these numbers by 6. And if I divide both of them by 6, 6 divided by 6 is 1. 54 divided by 6 is 9. Now I know that we just got done putting two separate ones under one square root, but what do I want to say? The shortcut part of it is, see how that allowed me to simplify the fraction? But it's not allowing me to actually take the square root. So I'm going to have to break it back apart into two separate pieces. So this is the square root of 1 over the square root of 9. Just making them individual again. And the reason this worked out so well, not only did it make the numbers smaller, you know, comparing the original to this one, the numbers we have left are perfect squares. So the square root of 1 is 1, because 1 times 1 is 1. And the square root of 9 is 3, because 3 times 3 is 9. So I end up with an answer of 1/3. But my main objective was to get rid of the square root in the denominator. So let's do just a couple more here. Okay, so this one here, I'm going to put it underneath one square root. And at a minimum, it's going to make the original numbers smaller numbers to work with. So both 65 and 5 can be divided by 5. So I'm going to divide them both by 5. 65 divided by 5 is 13, and 5 divided by 5 is 1. Okay, now I'm going to break this back apart into two separate square roots, square root of the numerator over the square root of the denominator. In this one, the denominator is the only one that's a perfect square. So square root of 13, there's nothing I can do with that. It's going to stay square root of 13. But the square root of 1 times 1 is 1. So the square root of 1 is 1. And if you take any number and divide it by 1, you get the original number. Like 10 divided by 1 is 10. 15 divided by 1 is 15. Square root of 13 divided by 1 is square root of 13. Okay, so here I'm going to put them underneath the same square root. Simplify this fraction. 7 fits into both 28 and 7. 28 divided by 7 is 4, and 7 divided by 7 is 1. Some of you at this moment might just say 4 divided by 1 is 4 and have the square root of 4 right now, but I'm going to just stay with the same pattern here. I'm going to break it back apart, so I have the square root of 4 over the square root of 1, and 2 times 2 is 4, so the square root of 4 is 2. 1 times 1 is 1, so the square root of 1 is 1. And 2 divided by 1 is 2. Now again, there's going to be some differences along the way. Somebody decides, oh, I know the answer to 4 divided by 1, it's 4. So they just have the square root of 4, which is 2. Okay, so let's do just one more. I'm going to put this under 1 square root, simplify the fraction. They're both even, so I'm going to divide them both by 2. 2 divided by 2 is 1. 72 divided by 2 is 36. Now that I've simplified the fraction, I'm going to break it back apart into 2 separate roots. So I have the square root of 1 over the square root of 36. They're both perfect squares. And the square root of 1 is 1, because 1 times 1 is 1. Square root of 36 is 6, because 6 times 6 is 36. And so I have 1 over 6. To recap your main idea, like, what am I seeing that makes me want to put them underneath the square root? The number in the numerator and denominator can both be divided by something. There's something in common. So by putting them underneath the same square root, I can simplify the fraction. And at a minimum, the numbers I'm working with are smaller. And then in these particular problems, what you have left over, they're going to be perfect squares. So we won't need any other strategies just yet.